Hello Year 10, this is the second half of your exam run through. This is just for double award. The first video that was for both double and triple, and that was the common material. This is just for double awarders. So again, please go through your corrections and write them into your class notebook or write them down on paper. And that will just help you get used to using some of the key terminology and phrases, and it will help you remember to some extent. Okay, question 1. Marble chips react with dilute hydrochloric acid. Marble is a form of calcium carbonate. Complete the balanced equation for this reaction. So you need to balance them. You'll have two hydrochloric acid molecules, you'll have a water molecule and carbon dioxide. So anytime you react acid with a metal carbonate, you always get a salt, water, and carbon dioxide. It does allow multiples. Explain how using smaller sized marble chips affects the rate of this reaction when all the other conditions remain the same. So here's our equation, and we're saying that we're going to use, instead of using a big marble chip, we're going to break that down into smaller pieces. So if we break that down into smaller pieces, we've got more area exposed. We've got a higher surface area. So we've got a higher surface area because all of this part in the middle, which was hidden, is now exposed. So we have a higher surface area, and then that means there'll be an increased rate of reaction. Okay. So rate increases, so the reaction is faster, or rate of reaction is faster, and that's because there's a larger surface area. Or you can say more collisions between the reacting particles. Okay, so remember this word particles just is a great word to use if you're unsure whether it's molecules, ions, or atoms. Okay, so I would say use particles. Okay, part 3. Explain in terms of collisions between particles how increasing the concentration of the hydrochloric acid affects the rate of this reaction. Okay, so going back to our equation, we are increasing the concentration of hydrochloric acid. This means that there's going to be more particles. Okay, you have to say there's going to be more particles in a given volume. You have to mention volume, because if you have you could have the same number of particles. You can have 6 particles in each, but if you have a higher volume in one, then you're going to have different concentrations. Okay, so you need to mention the volume. Your second mark you will get is for saying increased collisions, but you need to you need to mention per time, so per unit of time. So you'll have increased collisions per unit of time, and that's because you could have 2 reactant mixtures. You could have 1 collision each, so each of them has 1 collision. Okay, but this one happens over the space of 1 day. This one happens over the space of a year. So if you ask yourself which one's quicker, which one has a quicker rate of reaction, it's going to be the one that happens over a day as opposed to over a year. So you have to mention time in this. So if you go to our mark scheme here, you have to say more particles in the same volume of hydrochloric acid. Then your second mark is for more frequent collisions, and frequent. This just frequency means just a number, so that indicates time. So this is a safe phrase for you to use: more frequent collisions, or they collide more often, or higher rate of collisions. So that indicates time, and more often indicates the time here, and more collisions between hydrochloric acid and marble in given time. So you could just say in given time there. Okay, so it allows you to say molecules or ions, but not atoms, and this is why it's safer to just use particles. Okay, it says ignore more productive or successful or effective collisions, because we're not looking at that. We're just looking at the number of collisions. We're not looking about whether they're successful or effective or not. And it says ignore greater chance or probability of collisions, and ignore particles move faster or faster collisions. Okay, we're not increasing the energy, we're just increasing the concentration. So we're not heating them up, we're just increasing the concentration here. Okay, question 2. Dilute hydrochloric acid can be used to make salts. These salts are called chlorides. Which of the following will not react with dilute hydrochloric acid to produce zinc chloride? So if you've got hydrochloric acid, you want to add a base. Now, if you look at all 4 of these compounds, you'll see that they all begin with zinc. So at first glance, they all look like they can react with hydrochloric acid to form zinc chloride, but we actually need a base to do this. And if we look at the second part of the compound's name, you will see that the first 3 are what we call bases, because these are what you've studied. Bases always bases are always metal carbonates, metal hydroxides, or metal oxides. So your bases are just something which can neutralize acids to form a salt and water. Now, in carbonate's case, you also get carbon dioxide. So in a metal carbonate with acid, you'll get salt, water, and carbon dioxide. But with the other 2, hydroxide and oxide, you'll just get salt and water. Okay, so here you'll need to use process of elimination, and you'll see that the top 3 are bases, and then the answer must be zinc sulfate. This is actually a salt. Okay. B, a chloride salt can be made by adding an excess of solid base, so that's your top 3, your metal carbonate or metal hydroxide or metal oxide. So an excess of solid base to hydrochloric acid. Now, if you've got an excess of solid base, you're probably going to want to filter that out afterwards, just using your standard apparatus here. And when you filter it out, your solid base will be left as the residue. And then your solution here will be your salt solution, and that will be the filtrate. That will be the thing that's filtered. So the thing that's filtered is the filtrate, and the thing that resides left, or the substance that resides in the filter paper, is called the residue. And in this case, that's your base, your solid base. So it says here, identify which of the sequences of practical steps will be most effective in obtaining a pure dry sample of the chloride salt from the reaction mixture. So what you can do here is look at the first step and see if you can eliminate any of these options from the first step. So looking at the first step, you can see that the bottom 3 say filter and the top says heat. You're not going to want to heat. We've already established that we're going to want to filter the excess solid base. So it's going to be one of the bottom 3. Okay. So let's look at the second part now of the steps, of the sequence of steps. Heat the residue, heat the filtrate, or heat the filtrate. So we are going to want to heat this filtrate here, because this filtrate is going to be your salt solution. So you want to remove the water part from this solution, just so you're left with just solid salt crystals. So it's not going to be B as well. This means we can move on to the third step. The third step, and see if we can distinguish between the third step, and they're both different, so we probably can here. So it says leave to crystallize or wash the solid with distilled water. Now, anytime you're making crystals, a pure dry sample of a salt or crystals, you are going to want to leave to crystallize, and that's just to allow the water molecules to be trapped in the crystal structure. So if we look at our typical example of copper sulfate, you'll see that we'll see that your beautiful blue crystals, your hydrated copper sulfate, has water molecules trapped in the crystal structure, but our anhydrous copper sulfate, sorry, this is solid, both of these are solid, it doesn't matter what state they're in. So your copper sulfate, which is just a solid, your anhydrous copper sulfate, is actually just a white powder. They're not blue crystals. Okay, so in crystallization, you always want to give the solution time to crystallize. You want to heat the filtrate to saturation point, and then you want to leave it to crystallize. Okay, so it is going to be C. Okay, question 3. Sodium fluoride is an ionic compound containing sodium ions and fluoride ions. They've given us the charge of both of those. That's great. Sodium and fluoride ions are formed from sodium and fluorine atoms. So your atoms are neutral, they don't have a charge. Some information about sodium and fluorine atoms is given in the table. Fantastic, great. They've given us the protons, neutrons, and electron configuration for both of those atoms. Use the information in the table to describe the structure of sodium and fluorine atoms. Before I continue, I think we can break this question up because it's a long mark question. We can just answer this first part here, which is describe the structure of sodium and fluorine atoms. So this is quite easy, but it's even easier because they've given us this table. So let's try it here. So sodium has 11 protons and 12 neutrons in the nucleus. It has 3 electron shells and 1 valence electron, or 1 outer electron. So 1 valence electron. Okay, so once we've done the structure of the first one, the sentence structure for the first one, we can use that sentence structure for the second one as well, which is quite useful. So fluorine has 9 protons and 10 neutrons in the nucleus. It has 2 electron shells and 7 valence electrons. 7 valence electrons. Fantastic. So we've described the structure of sodium and fluorine atoms. That's probably going to give us around 4 marks. And how they combine to form sodium and fluoride ions. So we can answer the second part. So how do they form sodium and fluoride ions in sodium fluoride? So if we look at the electron configuration, if you remember, all atoms, when they react, they're trying to get a full outer shell of 8 or 2 if it's the first shell. So in sodium, we have 1 valence electron. So that's going to want to lose that electron to reveal the outer shell underneath. Then fluorine is going to want to gain an electron because it has 7 in its outer shell to gain a full outer shell. So writing that down, we can say that sodium loses 1 outer electron, or 1 valence electron to form a sodium ion. Okay, whilst fluorine gains 1 electron to form fluorine ion. Okay, so we've answered both of those questions. So we've answered both of those points. There's one thing we haven't answered though, and this is this combine word here. So how they combine to form sodium and fluoride ions. So in combining, we can say that oppositely charged ions attract. Perfect. So that's our 6 marks. That's taken me roughly 3 minutes. So it's quite an easy question, but it does take practice and this way of breaking down a question to help you there. So you can also use diagrams to help you with your answer. Now I drew this diagram earlier, and this diagram pretty much says exactly what this description says. So you can use something like this to help you, but note you can't just use a diagram for the whole question because it does say you may use diagrams to help your answer, or it doesn't say you may use a diagram to answer your question. Okay, so only to help. So this diagram here says everything that I've written here. Now you would have got marks for each of these points, or this is what the examiner is looking for, these points, and we've actually covered all of these points. So protons and neutrons in the nucleus, yes. Electrons in shells, electron shells surround the nucleus. The amount of electron shells both atoms have, yes. Sodium loses 1, fluorine gains 1, yes, to form a sodium plus ion and a fluorine minus ion, yep. Electron transfer from sodium to fluorine, yep, and then opposite ions attract. Perfect. So we've actually answered all those points there, and we would have got 6 marks for that. If we look at the second part of the mark scheme, it says here that to get 6 marks, you only need one of the following. So a detailed explanation of the atomic structure of the atoms of both elements. So we've done that at the top here. Or how ions of both elements are formed. So we've done that at the bottom. So we've actually done more than what is needed. So we definitely would have got 6 marks there. Okay. Question 4. Which row of the table correctly shows the boiling point and ability to conduct electricity of a simple molecular covalent liquid? So it's given us the structure here, which is simple molecular. So if it's simple molecular, you're going to have molecules. So I'll draw some molecules here. And in between these molecules, you're going to have weak intermolecular forces. Okay, those weak intermolecular forces, they require little energy to overcome. Okay, so it's going to have a low boiling point. So we can cross off B and D because they have high boiling points. And the fact that it's also liquid tells us that it's got a low boiling point, because substances with high boiling points are normally solid at room temperature, so metals and diamond. So weak intermolecular forces and no energy. It also says the ability to conduct electricity. Now, to conduct electricity, you need charged particles, and that's either ions or electrons, and they also need to be mobile. They also need to be free to move. Now, in your simple molecular, you don't have charged particles. Okay, so it's going to be a poor conductor of electricity. Okay, so that's going to be C, our answer. Question 5. Sodium sulfate is an ionic solid which is soluble in water. Which row of the table shows the likely properties of sodium sulfate? So if it's an ionic structure, it's going to have a high melting point. Okay, and that's just because of many strong ionic bonds. And that requires a lot of energy, so a lot of energy to break those bonds. Okay, so it's going to have a high melting point, so we can cross off B, A and B, and then conducts electricity when dissolved in water. Let's see if it's soluble in water. It's an ionic compound, and you have, remember, the two things that you need are charged particles. So you have ions in this case, and they need to be mobile. Because it's dissolved, they are mobile. Okay, so it will conduct electricity. So your answer is C for this one. Question 6. Copper reacts with oxygen to form copper oxide. Calculate the maximum mass of copper oxide. I'm just going to stop there because any questions here when you're calculating mass or moles or concentration or anything like that, you should always lay out using the table method. So on one side, just put down all the information that you've got, moles, mass, MR, and then put your balance symbol equation at the top. Ensure that this is balanced, because the mole ratio is something that we use to calculate the mass of another product. So we need to have the correct mole ratios here. Okay, and we've got a mole ratio of 2, 1, 2. Okay, so the mole ratio is very important in a balanced symbol equation. So it says here, calculate the maximum mass of copper oxide. So that's what we're calculating. I'll put a question mark there. That could be formed by reacting 25.4 grams of copper with excess oxygen. So put 25.4 grams of copper here. We have an excess of oxygen, so we don't need to work out how much oxygen is going to react. We can work it out if we want to, but we don't need to in this question. The reaction here is going to be limited by the amount of copper we have, and that's 25.4 grams. You can't make any more copper oxide once that copper has run out, because copper oxide contains copper. So it's going to be limited by this reactant. So other information, now we need to find out the moles of copper oxide, and then when we've worked out the moles, we know how many moles of copper oxide we're going to make, and then we can work out the mass of our copper oxide. So to work out the moles of copper, we need the MR for copper, and we've got that in the table. It's very nice they've given it us. Then we need to use the equation which you know out of your head, which you should know out of your head, moles equals mass over MR, to work out the moles of copper. Okay, so we do mass divided by MR, it's 25.4 divided by 63.5, which equals 0.4. Now we know our mole ratio is 2 to 2. So that's pretty much the same as saying 1 to 1. You can simplify that as saying 1 to 1. So if you have 0.4 moles of copper, then you're going to have 0.4 moles of copper oxide. Just like moles is just a number. Okay, so if you have 12 dozen, if you have a dozen copper molecules, you're going to have a dozen copper oxide molecules. Okay, so it's just the same. Just like if you have 4 copper atoms, you're going to have 4 copper oxide molecules. Okay, so we're just saying the same thing now with our mole ratio. Now we can work out the mass, but we need the MR first, and they give us the MR in the top there, which is very handy. We don't have to calculate it. So that's very handy for us. Then using this equation, we can rearrange it. So bring MR to the other side, so it's divide MR here, bring it to the other side, change the function, is now times. So we do MR times mol equals mass. So if we times these two numbers, we should get the answer 31.8 grams, and that's the 3 significant figures. If in doubt, always put to 3 significant figures, unless the question specifies otherwise. In the previous video, the question specified 2 decimal places. Question 7. Equation 1 below represents a reaction using cobalt-2 chloride that can be used to show a liquid contains water. In this reaction, there is a colour change from blue to pink. Which word describes both cobalt compounds in equation 1? So if we circle the 2 compounds, we can then go through each of the choices one by one and see if we can cross any off. So anhydrous, so both of these contain water of crystallization. So it's not going to be anhydrous. What about aqueous? So let's look at the state symbol next to it. No, they're both solid, so they're not aqueous, so we can cross that off. What about hydrated? So they both have water molecules present, they both have water of crystallization, so yeah, could be hydrated. And what about saturated? Well, I don't really know what they mean by saturated here, because normally we refer to bonds being saturated, but if they were referring to water of crystallization, well, the first cobalt compound, that can contain more water. So that can actually contain 6 water molecules, and maybe even more, who knows, but it can definitely contain more, and so it's not going to be saturated in this case, so it is going to be hydrated. Okay, so whenever you're looking through multiple choice questions, do try and do it like that. Do try to use the process of elimination. Good exam technique there. Part 2. When the product in equation 1 is gently heated, another reaction occurs. Equation 2 represents this reaction. So if you look at equation 2 in comparison to equation 1, you'll see that they're both the same, but they are reversed. That gives us the answer to the next one. It says, what do equations 1 and 2 suggest about the reactions? They're reversible, so they can go in both directions or go backwards. Any of those would have given you the mark.